There are many different trends across the periodic table. Each group has its own unique set of properties. We are going to look at the trends of groups 0, 1 and then 7. Group 0 contains the noble gases. All group 0 elements have a full outer electron shell. Because the atoms have full outer shells, they do not want to lose or gain electrons. They already have the most stable configuration. However, some of the larger atoms are slightly reactive with elements such as oxygen and fluorine. One of these is xenon. All of the noble gases have very low boiling temperatures, and the boiling temperatures increase as you go down the group. Helium, at the top of the group, has a boiling temperature of -269 degrees Celsius, and radon, at the bottom of the group, has a boiling temperature of -62 degrees Celsius. Group 1 contains the alkali metals. All these elements have one electron in the outer electron shell. The electron is very easy to lose, and so the elements are very reactive. As you go down group 1, the atoms get larger. As the atoms get larger, the positive attraction of the nucleus on the outer electron decreases. The outer electron also experiences the shielding effect from inner electrons. This means that the attraction between the electron and the nucleus is reduced. This leads to the electron being lost more easily, and therefore the reactivity of the group increases as you go down the group. The group 1 elements all react with oxygen, and so they have to be stored in oil. When these elements react with oxygen, the product is the metal oxide. For example, lithium reacts with oxygen, producing lithium oxide. These reactions are vigorous. The group 1 metals also react with water. The first 3 elements, lithium, sodium, potassium, all react vigorously with water. In these reactions, a metal hydroxide and hydrogen are formed. For example, sodium reacts with water to produce sodium hydroxide and hydrogen gas. These metal hydroxides are soluble strong alkalis with high pHs. This is where they get the name alkali metals from. During the reaction, the metal moves around, fizzing on the surface of the water. This reaction is so vigorous that the metal ions produced burn. Group 1 metal ions have distinctive flame colours when they burn, and so during the reaction with water, you can see a coloured flame, such as lilac flame for potassium ions. The group 1 metals will react with non-metals, such as those in group 7. For example, with chlorine, producing a metal chloride, which is soluble in water. The elements in group 1 are all solids. However, these metals have a relatively low melting temperatures. This means that they are soft and can be easily cut with a knife. The melting temperatures of the metals decrease down the group. Lithium, at the top of the group, has a melting temperature of 180.5 degrees Celsius, and cesium, at the bottom of the group, has a melting temperature of 29 degrees Celsius. The metals are shiny and silvery, but when cut, the metal reacts with oxygen in the air, and so they become dull as the metal oxide is formed. The group 1 metals also have very low densities. The elements of group 7 are called the halogens. The halogens are a group of reactive non-metals. The reactivity of these elements decreases as you go down the group. This is because it is more difficult for the atoms to gain the electrons they need as they get larger. To demonstrate the descending reactivity of the halogens, we will look at the reactions of fluorine, chlorine, bromine and iodine with iron wool. Fluorine reacts instantly and violently. When the wool is heated, chlorine will react very quickly with it. For bromine to react with the iron wool, both the bromine and the wool have to be heated, and this reaction is fast. Iodine reacts slowly with iron wool. As you go down group 7, just as with other groups, the atoms become larger. This means that the outer electron shell is further away from the positive effect of the nucleus. As a result, it is more difficult for the atoms to gain the electron they require to obtain a full outer electron shell. Other factors related to the size of the atom also affect the reactivity. These factors include the shielding effect and the new nuclear charge. The shielding effect involves the inner electrons of the atoms. These electrons reduce the electrostatic forces of attraction between the electron to be gained and the nucleus. As the atoms get larger, there are more inner electrons, and so there is more repulsion, making it more difficult to gain an electron. The nuclear charge is due to the number of protons. The larger the atom, the more protons, and so the greater the nuclear charge. This means that there are greater forces of attraction from the nucleus on the electrons, and so in theory, it should make it easier to gain an electron. However, the distance and shielding effect outweigh the positive effect of increased nuclear charge. This is why the elements of group 7 become less reactive as you go down the group. Displacement reactions can be used to determine the order of reactivity of the halogens. A displacement reaction works because a more reactive halogen is able to displace a less reactive halogen from a solution of its salt. This means the elements at the top of the group 7 will displace those from the bottom. Fluorine is able to displace all of the elements in group 7 from their salts, whereas iodine cannot displace fluorine, chlorine or bromine. An example of a displacement reaction is adding chlorine to sodium bromide. In this reaction the chlorine is more reactive and so will displace the bromine from the sodium bromide solution. If you were to add a solution of sodium chloride to the iodine, no reaction would occur. The melting and boiling temperatures of the elements increases as you go down the group, with fluorine and chlorine at the top being gases, bromine in the middle being a liquid and iodine being a solid. The halogens are non-metals and so are poor conductors, and they also exist as diatomic molecules. This means they are pairs of atoms held together by covalent bonds.